Welcome, my dear student, in our math program for secondary 3. Dear student, today we are taking new lesson in algebra. Its title, determinants. Determinants, what you meaning of determinants? Look at introduction of determinants. Definition. It is a value associated with a square matrix. It can be computed from enters of matrix by specific arithmetic expression, while other ways to determine its values exist as well. Determinants also are mathematical objects that are very useful in the analysis and solution of the system of linear equation, where the determinants of degree n consists of n rows and n columns. Type of determinants. Number A, determinant of the first degree. What do you mean of the determinant of the first degree, dear student? D1 equal determinant of A11. A11 element has one row and one column, as equals value 1 A11. For example, determinant x, determinant 6 equal 6. Determinant of the second degree. Second degree has 2 rows, 2 columns. 2 rows, 2 columns as a figure. A11, A12, A21, A22. What do you mean of 1 A12, dear student? Element in first row, second column. What do you mean of A21? Second column, second row, first column. 1 1, first column, first row, first column. Start from the row. What is the value of D2? Cross multiplication, A11 times A22 minus A12 times A21. For example, look at determinant 3, 4, 2, 5. 3, 4, 2, 5 equals 3 times 5 minus 4 times 2 equals 3 times 5, 15, minus 4 times 2 equals 7. Determinant of the third degree. What do you mean of the determinant of the third degree? Dear student, D3 equals 3 rows and 3 columns as the figure A11, A12, A13, A21, A22, A23, A31, A32, A33 equals A11 multiply square or second determinant plus 1 A1, A11 multiply the determinant contains A22, A23, A32, A33 minus A12 multiply the second determinant A21, A23, A31, A33 plus A13 multiply its determinant. Each number has or each element has determinant. A11 has determinant. A12 has determinant. A13 has determinant. Look at the sign. The first sign positive, negative, positive. Positive, negative, positive. Remember, dear student, the sign of the cofactor of elements of determinant are positive, negative, positive, negative, positive, negative, positive, negative, positive by using the columns. Also by using the row as the column. Positive, negative, positive, negative, positive, negative, positive, negative, positive. Start from the positive, look at end of the positive. Starts from the positive to end to the positive. Expand determine the expansion of A11, A21, A31, A12, A22, A32, A13, A23, A33 by using the column. By using the row, A11, A12, A13. A11 multiply A22 multiply A33 minus A23 times A32 by cross multiplication. Also negative A12 plus A12 by determinant of cofactor. Example. Expand using the factors of the second row. D3 equals 1, 0, negative 2, negative 2, 4, 3, 3, negative 1, 5. Solution. Let us the second row, D3, negative 2, start from negative 2. Multiply coefficient factor. What's the coefficient factor of negative 2? 0, negative 2, negative 1, 5. Plus 4, the second element. Multiply the cofactor of 4, 1, negative 2, 3, 5, negative 3, multiply determinant of it, 1, 0, 3, negative 1. Therefore, 2 multiply 0 times 5, negative, multiply, bracket contains negative 1, multiply negative 2, plus 4 multiply 1 cross multiplication, 1 times 5, negative, bracket contains negative 2 times 3, negative 3 multiply, bracket contains 1 times negative 1, negative 3 times 0 equals 2 times negative 2 plus 4 times 11, negative 3 times negative 1, negative 4 plus 44 plus 3, answer is 43. Remember that, dear student, look at example. Solve the equation. What do you mean because solve the equation of determinant? Find the value of x. Solution. We find the value of determinant x multiply 6x minus 6 multiply x plus 1 minus 2x plus 1 side bracket multiply bracket negative 3x negative 0 plus 0 multiply negative 6 negative 0 equals 0. Therefore, negative 6x plus 6x power 2 plus 3x equals 0 by using like terms. 6x power 2 equal negative 3x equals 0. Therefore, 3x highest common factor multiply 2x minus 1 equals 0. Therefore, 3x equals 0, x equals 0, and 2x minus 1 equals 0. Therefore, 2x equals 1, x equals 1 over 2. Another example. If omega is 1 of cubic root of 1 and I equals square root negative I, prove that 1, look at the determinant equal 0. 1 I omega I minus omega 0 omega square I negative omega square omega equals 0. Remember, dear student, omega square times omega equal omega 3 equals 1. Omega minus omega square positive or negative square root I power 2 equals negative 1. I equals square root negative 1. Look at, dear student, d1 equals 1 times cofactor determine negative I multiply cofactor determinant plus omega square multiply what? Cofactor determinant. 1 multiply negative omega times omega negative omega square plus omega square. Negative I multiply omega square I minus 0 plus omega square times negative omega 3I minus negative omega 3I. Negative negative positive. becomes equals, answer is negative omega square I plus omega square times 0. Therefore, answer is negative omega square plus omega square equals 0. The determinant is equals 0. Properties of the determinants. Number 1, from the properties, the value of determinant doesn't change if its row replaced by its column of the same order and vice versa. Remember, dear student, the value of the determinant doesn't change if its rows replaced by its columns of the same order and vice versa. Vice versa means if we replace second column by the second row, the determinant values not change. Example. Look at determinant 2, 5, negative 1, 0, 3, 4, 0, negative 2, 1 equals, yes, 2, 5, negative 1, 0, 3, 4, 0, negative 2, 1. Number 2, the values of determinant is unchanged by expansion in terms of the elements of any 8 row or columns. The values of determinant is unchanged by expand it in the terms of the elements of any of 8 row or columns. Let D3 equals 3, negative 5, 9, 1, 2, negative 4, 4, 0, 0. Look at using the first row, we find the value of determinant 3 times 0, 5 times 0 minus 16 inside bracket, plus 9 times 0 minus 8 inside bracket, equals 80 minus 72 equals what? Equals 8. Using third column, D3 equals 9 times bracket contains 0 minus 8 plus 4 multiply bracket 0 minus 20 plus 0 multiply 6 plus 5 equals negative 72 plus 80 also equals 8. Third column, by using third column, determinant equals 8. Third row, answer or determinant is equals 8. Not a change. Number 3, if 2 rows or columns of determinant exchanged their position, the value of resulting determinant equal negative value of the original one. Remember, if we replace 2 rows or 2 columns, the values equals negative value of the original one. Example. Look at determinant 2, 5, negative 1, 1, 3, 0, 7, negative 2, 0 equals negative 1, 2, 7, 3, 5, negative 2 by column 0, negative 1, 0. We replace by changing R1, replace R2. Number 4, the value of determinant equals 0 if all the elements of one of each row, column or column are zeros. Remember, dear student, the value of determinant equals 0 if all elements of one of each row or columns are equals zeros. Example, look at the determinant. Third row, all elements is 0. The determinant is equals 0. Because R3, all elements in R3 equal 0. Number 5. If the corresponding elements in 2 rows, columns of any determinant are equals, then the value of determinant is equal 0. Remember, very important properties. The values of determinant is 0 if all elements in the 2 rows or 2 columns are same. Look at the example. Determinant of third degree 335, 114, 226. This determinant is value equals 0. Why? Look at C1, C2, column 1, column 2. Column 1, 312, column 2, 312 are same, all elements are same. Answer is equal 0. Because C1, C2 equals 0. Dear student, from important properties number 3 and number 4, the determinant its value equals 0 if all elements in row or columns are equal to 0. Also, when we find all elements in the 2 rows or 2 columns are same, also the values equal 0. The values equal 0 in 2 cases. The first case, all elements in the row or the column equal 0. And the second case, if all elements in 2 rows or 2 columns are same, then the value of determinant is equal 0. Dear student, look at the another property. If k is a common factor of elements of any of the row or column of determinant, k is a factor of this determinant. Look at example. We have determinant of third degree 2, -5, 3, 4, 15, 1, 3, 10, 2. We can take common factor from C2, 5. Answer is 5 multiply determinant of the third degree 2, -1, 3, 4, 3, 1, 3, 2, 2. 5 is common factor is k. By taking 5 as a common factor from the second column, answer is the original. Example. Prove that, dear student, look at determinant. Left hand side is BC, A, A2, CA, B, B square, AB, C, C square equals 1 A square, A power 3, 1 B square, B power 3, 1 C square, C power 3. Look at the proof. Multiplying R1 times A, R2 times B, R3 times C in determinant of left hand side and divided by A, B, C. Remember, dear student, first row we multiply it by A, second row we multiply it by B, third row multiply it by C, after that dividing by A, B, C. Look at left hand side becomes 1 over ABC multiply determinant of the third degree ABC, A square, A power 3, multiply the first row by A, multiply the second row by B, multiply third row by C. Left hand side becomes ABC over ABC by using highest common factor from C1 or from the first column. Answer is ABC over ABC, 1, 1, 1, first column, A2, B2, C2, second column, A3, B3, C3 in third column equals right hand side, because ABC over ABC equal 1. Determinant becomes 1 A square A power 3, A B square B power 3, 1 C square C power 3. Look at another example. Without expanding, prove that determinant of third degree equals 0. Look at determinant 0 KL, negative K OM, negative L, negative M, 0 equals 0 without expanding by using the properties where K, 1M are any values, KLM are any values. By taking negative 1 as common factor from R1, R2, R3, look at R1, R2, R3, first row, second row, third row, taking negative 1 common, the determinant becomes negative 1 multiplied determinant of third degree, 0 negative K negative L, K 0 negative M, L M 0. Look at, dear student, change row columns. Look at, we are change all rows and all columns. Determinant becomes negative 1 multiply determinant 0 KL, negative K 0 M, negative L, negative M 0. Determinant equals negative 1 times D, the first. Therefore, negative D equals D, therefore 2D equals 0. After that, divided by 2, the determinant equals 0 equals right hand side. Number 7, this property number 7, n determinant of all elements of any row or columns are written as the sum of two elements. Then the value of the determinant can be written as the sum of the two determinants. Look at the example. Clear that. Look at, dear student, we have determinant of third degree contains 3 row and 3 column. First row AD x plus 1. Second row BE y plus m. Third row CF z plus m. Look at, dear student, A, B, C, D, E, F, column, 3 column, X, Y, Z. We divided the third column by 2 columns, plus second determinant, A, B, C, D, E, F, 1, M, L, M, N, L, M, N. Dear student, we have determinant. The first determinant AD x plus L, BE y plus m, CF z plus n. We divided the determinant by the two determinants. Two determinants has, look at the third column, x plus L, y plus m, z plus n. We divided into two determinants, not to change the 2 columns, but the third column divided it into 2 columns as the figure. Example. Prove that. Look at the first determinant, second determinant equal 0. First determinant 4, negative 1, 6, negative 7, 3, negative 9, 2, 0, 1, plus second determinant 4, negative 1, 3, negative 7, 3, 5, 2, 0, 8. Third determinant negative 2, 1, 6, negative 7, 3, negative 4, 2, 0, 9. Dear student, look at the first and the second determinant. The first column, second column are same. Look at the first and the second column in the two determinants. 4, negative 7, 2 in the first column, in the first determinant is same 4, negative 7, 2, the first column in the second determinant. Negative 1, 3, 0, C2 in the first determinant is same negative 1, 3, 0 in the second determinant. Look at the solution. By using C1, C2 are identical in D1, D2, therefore D1 plus D2 equals D. Therefore, we add D1 plus D2, the first column, second column, 4, negative 7, 2, first column, negative 1, 3, 0, second column, third column, negative 3 plus 6, negative 9 plus 1, 1 plus 8, equals 4, negative 7, 2, first column, negative 1, 3, 0, second column, 3, negative 4, 9, third column. We add determinant number 1, determinant number 2. After that, we add, look at R1, R2 are identical in D and D3. Look at D, we add 4 minus 2, negative 1 plus 1, 3 plus 6, negative 7, 3, negative 4, 2, 0, 9. Therefore, answer is determinant of the third degree 2, 0, 9, negative 7, 3, negative 4, 2, 0, 9. Look at the first and third rows are same in elements. 2, 0, 9, first row, third row, 2, 0, 9. Answer is 0. Why? Because if we have two rows, all elements in them are same, the value of determinant equals 0, the second property, since R1 equal R3. D1 plus D2 equal D. Therefore, 5 minus 2, negative 7, 2 first column, negative 1 plus negative 1, 3, 0 second column, negative 3 plus 6, negative 9 plus 5, 9 in third column, equals what? Equals 2, negative 7, 2, negative 1, 3, 0, 3, negative 4, 9. Therefore, we are translate to the properties number 8. Dear student, now we are translate to end of the determinant lesson. Remember, dear student, very important determinant lesson and its properties. I am very happy to spend such time with you. Math simple, think, work, produce. Goodbye.